Hey everyone, in this video we're going to talk about polynomials. So first let's write down exactly what a polynomial is. Polynomial. So a polynomial is an expression. So it's an expression of terms bound by addition and subtraction. So it's an expression of terms that are bound together by addition and subtraction. And let's write down what these terms look like. So they all have the form of a times some variable x we'll use to the power of n. So this is one of the terms of a polynomial. They all take this form. And let's look at an example of a polynomial. Let's say we had x squared minus 5x plus 6. Scroll down a little bit. So x squared minus 5x plus 6. So as you can see right here, there are three terms. There's x squared, there's negative 5x, and there's positive 6. So those are the three terms, and they all take this form, a times x to the n power. And I'll show you exactly how. Let's look at this first term right here, x squared. What exactly would the a be? Well, there's no number in front of it. There's no number. So whenever there's no number in front of a term, that number is always 1. And that is because 1 times any number is always itself. 1 times x squared is simply just x squared. So the a in this case would be 1. 1 times, let's write down the variable in green, x. And then, of course, the exponent right there is 2. Now let's write down the second term in the same form. What is a in this case? That is negative 5. And just to make it clear that these terms are bound by addition, we're going to be adding all of them. We're going to add these terms. And what is a in the second term's case? It is just this negative 5. Let's get rid of that. Negative 5 times, and the variable is x. Now you can see there's no exponent up here. So whenever there's no exponent, the exponent is always 1. Because anything raised to the first power is itself. X raised to the first power is x. That's how you write that in a x to the n form. And now this third term right here, positive 6. Let me rewrite that. Positive 6. So you can probably tell the a in this case is positive 6, or we could just write 6. And even though there's no variable over here, the variable would actually be, so x to the 0 power. And that is because, let's just write it down right here, x to the 0 power is 1. Anything to the 0 power except 0 to the 0. Besides that, anything to the 0 power is 1. So this is really just 1, and that comes out to 6 times 1, which is 6. So that's how you write this polynomial in ax to the n form. And this shows you why it's a polynomial, because there are three terms here. 1, 2, 3. They're all bound by addition or subtraction. And that's what makes a polynomial. Now, let's go through a few quick examples of polynomials, of different types of them. So we have, scroll down a little bit more, we have monomials, binomials, and trinomials. Monomials, binomials, and trinomials. So an example of a monomial is 2x to the third power. Of a binomial, let's use a different variable instead of x. Let's say 2z to the fifth power plus 9. And a trinomial, maybe we'll use 3y squared plus 5y minus 12. So how many terms are in each of these polynomials? So what makes a monomial is that it has exactly one term. There's one term in this monomial, and a binomial is a polynomial with two terms. There's two terms right here, 2z to the fifth power and positive 9. There are two terms. And a trinomial has three terms. One is 3y squared, and then we also have positive 5y and negative 12. There are three terms right here. So monomial, binomial, and trinomial. And that's what differentiates them. Monomial has one term, binomial has two, trinomial has three. So now let's talk about the degree of each of these. So the degree of a polynomial. So the degree of a polynomial is the highest exponent of one of the terms. So right here in this monomial, there's only one exponent. It's this 3 right here. So the degree of this is 3. Now in this binomial, we have, you can't see it, but we actually have two exponents. We have this 5 here, and this positive 9, if you write it down in ax to the n form, this is times x to the 0 power. So we also have this 0 right here. So you take the higher of the two, the 5 of the 0. 5 is a higher exponent. So the degree of this binomial is 5. And right here we have three exponents in this trinomial. We have this 2 right here. And although you can't see it, there is a 1. This is y to the first power. There's a 1. And again, right here in this negative 12 term, this is negative 12 times x to the 0. And 2, 1, and 0 are exponents. So what is the highest one? That is 2. Let me make some room here. The degree of this trinomial is 2. So though that's how you find the degree of a polynomial, now let's talk about the leading term. So let's erase these, erase that as well. Okay, so let's talk about the leading term. And I'll just underline what the leading term is in each of these. The leading term, and let's just get rid of these underlines from these underlines before. The leading term is the term with the highest exponent. So in this monomial, there's only one term. So of course, that's the leading term. And this binomial, there are two terms. But which one is the leading term? Well, which one has the highest exponent? It's this one, 2z to the power of 5. It has an exponent of 5, which is greater than this 9's exponent right here. And in this trinomial down here, which one is the leading term? Remember, there's three terms. There's the 3y squared, 5y to the first, and negative 12. Which one has the highest exponent? That would be the 3y squared, because it has an exponent, it has a variable with the exponent of 2. The 3y squared is the leading term. So now that we identified the leading terms, let's talk quickly about another term, coefficients. So you write that down again to be So coefficient. So a coefficient is the number that's being multiplied by the variable in the term. The coefficient is essentially the a in a times x to the n. A is also known as it's called a coefficient. So let's find the coefficient of each of these terms. We could see right here there's only one term. The coefficient is 2, because that would be the a in that term. And let's identify the coefficients here. There's the 2 right there in front of the z to the 5th, and there's also the positive 9. And right here in this trinomial, there's a coefficient in front of this 3y squared, that's 3. And the coefficient of this 5y to the first is 5. And the coefficient over here, this negative 12 times y to the 0, which is just negative 12, that the coefficient is just negative 12. So those are some important terms, or some important words to understand when talking about polynomials. Now let's scroll down a little bit and let's go through an example of a polynomial, that's a little bit larger. So let's say we had 3x minus 4x plus 5x squared minus 2x to the third minus 6x squared. Okay, so we have this large polynomial right here. So we can identify the degree of this polynomial. If you just take a quick scan, the highest exponent you can see is 3. So this is a third degree polynomial. And then we can underline all their coefficients as well. So there's a 3, negative 4, positive 5, negative 2, and negative 6. So those are all of the coefficients. And how many terms are there? Well, we can also count that as well. There's this 3x, negative 4x, positive 5x squared, negative 2x to the third, negative 6x squared. So 1, 2, 3, 4, 5. There are 5 terms. This is a 5-term polynomial. And let's talk about how to simplify this polynomial. So in previous videos, we talked about combining like terms. So like terms. And let's talk about that one more time with polynomials. So two terms are like terms when they have the same variable and the same exponent. So if they have the same variable and the same exponent, they are like terms. So let's go ahead and identify some like terms here. We have this 3x and negative 4x. Why are they like terms? Is because they have the same variable, x, here, and they also have their variables have the same exponent to the first power, x to the first power, right there. So those two are like terms. What else is a like term is this positive 5x squared and negative 6x squared. You double underline those. And again, the reason they're like terms is because they both have the same variable, x, and the same exponent, the power of 2. So those two are like terms. And then we're left with this negative 2x to the power of 3. There's no other like terms with it because although it has the same variable x, it doesn't have the same exponent as any of the other ones. There's no other term here that has an exponent of 3. Perfect. So let's combine these like terms. What is 3x minus 4x? And when combining like terms, just ask yourself first, just ignoring the terms, what are the numbers, or what is 3 minus 4, basically. So 3 minus 4 is negative 1. Therefore, 3x minus 4x is negative 1x, which we can, negative 1x, we can also write as negative x. It's the same thing. And right here, positive 5x to the second minus 6x to the second. So plus 5x squared minus 6x squared. Well, what's 5 minus 6? That's negative 1. So 5x squared minus 6x squared is negative 1x squared, or also just negative x squared. And then we're left with this term right here, negative 2x to the third. So we've simplified this polynomial, and now there are only 3 terms remaining. It's a trinomial now. And whenever you write out a polynomial, you always want to write it in order with the leading term first. So again, what's the leading term? It's the term with the highest exponent. The highest exponent is 3. So negative 2x to the third is the leading term. So let's write that first, negative 2x to the third. And what's the second highest exponent? 2. So let's write down that term next, that entire term, negative x squared. And then what do we have remaining? This minus x. And there we go. That's how we simplify and rearrange that polynomial. So I hope this video helps you understand polynomials more. And if you have any questions at all, please leave them in the comments below. And thank you for watching.